So one of the first retrieval augmented generation approaches in papers like Realm and RAG for knowledge-intensive tasks used a single step of retrieval to generate the answer. So here, what we essentially did was we took the query as input. A query encoder like BERT was used to compute similarity with a large number of document embeddings, and subsequent classification or generation was conditioned on this document embedding. And the generator was trained using classic language modeling approaches like mass language modeling. And some of these approaches also backpropagated to update the query encoder, and at some frequent or infrequent intervals, the document embeddings were also updated with the updated encoder. However, most of these approaches used a single step RAG approaches, wherein retrieval was just called once, using the original question as the user query. And this meant it was hard to answer more complex user questions, which would require multiple retrieval calls, like when information sources were spread across multiple documents. IRCOT introduced an interleaved reasoning and retrieval loop. So instead of retrieving once, the model first generates a small piece of reasoning, that is, a small set of reasoning tokens, like a partial chain of thought. And that intermediate reasoning is then used to form a better retrieval query, which brings in more relevant evidence. And then the model continues reasoning, retrieves again if needed, and repeats this process. So the authors find that interleaving reasoning with retrieval significantly improves both retrieval quality and the final answer accuracy on multi-hop tasks. And they found that improves as compared to one-shot retrieval, wherein a single query is used to retrieve documents. And there were many papers which perform multi-step retrieval, especially in open domain QA, right from 2019, 2018, possibly before that as well, um, before chain of thought and reasoning chains were common. And this is an interesting one or interesting paper because it does that by interleaving the chain of thought tokens with retrieval. So approaches like IRCOT were used during inference time. Instead, in Toolformer, the authors trained the LLM to generate such tokens. So, in fact, they generalized to some more tokens apart from search, like a calculator or a calendar API. So, what they essentially did was they first artificially generated training data. So, they took general text, and then they substituted an entity with an API call. So, they only substituted with an API call if the subsequent token losses were reduced by keeping the API call. So in the right figure, you can see how a QA tool call is inserted. And during runtime, whenever such tool calls were generated, the generation was paused, a retriever was invoked, and the resulting answer from the retriever was substituted back instead of the tool call. So in that way, the LLM had complete control of calling external tools by just generating these tool tokens. Now we looked at RL approaches like GRPO in the context of math and logic problems, and we also looked at Toolformer, how it used supervised fine-tuning in order to generate search calls. In the math and logic problems of GRPO, the task was simple, at least from the point of view of design. We had a question, and the policy generated rollouts, and then depending on whether the rollout gets the correct answer, GRPO gave a reward of 1 or 0. So in that setting, when your task doesn't require information, in that setting, the task does not require information from outside of the weights. Now, in this approach, search R1 or research, the approach is not much different, except that the policy rollouts can now make external calls to a search engine or a retriever, just the way we saw in Toolformer. And how they do that is by defining a template to instruct the model to generate search queries through search tokens. And during the rollout generation phase, whenever you encounter a piece of text enclosed in these search tokens, you pause, call a retriever with the query, and then come back and append the retrieved passages through these information tokens. And then continue the generation until you generate the final answer. And what is the reward? The reward is simply 1 when when the answer in the answer parentheses matches your ground truth. So let's try to look at it again once a little bit carefully. We have our input query X, our policy model, uh, some search engine or a retriever, and a maximum action budget, which will restrict the number of retrieval calls that we can do. We start generating tokens uh, from our input and whatever we have generated till now. And if the new token is basically an end of search token or an end of answer token or an end of sequence token, then we break. Else we continue to generate these tokens. Then we check if we have a end of search, start of search and end of search tokens in our complete sequence. If we have that, then we extract that to get a search query. Once we get the search query, then we call the retriever, get the document, and insert the document back again in our rollout enclosed in the information tokens. Or else, if we have answer parentheses detected in the rollout, then we return a final response. S- So, one important thing worth glossing over is the loss masking for retrieval tokens. So in GRPO, once the model generates the rollouts, we compute the loss over the tokens of the rollout sequence and then multiply it with the reward and then perform policy gradient. But now in these rollouts, in search R1, we have tokens from external passages as well, and they might have a completely different distribution than our policy model, and that would affect training dynamics. And that is what the authors actually observe. So the authors, they do an interesting thing. They mask these retrieve tokens during loss computation and find that that actually improves training stability drastically. So you can see search R1 with mask has an average of 0.431, but search R1 without mask, the average score decreases. And they find that for two different models as well. So in a nutshell, you can understand the kinds of behaviors you can train with such a setting like Toolformer or Search R1, and one can extend this to end-to-end training to perform tool calling or any sort of tool calling, for instance. So, along with Toolformer, Search R1, and a couple of other papers, there were many papers which tried to have subsequent works, and they were all very interesting. For instance, one is R1 Searcher. Uh, R1 Searcher used reinforcement learning to train in a for this multi-hop QA RAG task in a phased manner. So it was a two-stage manner. So in the first stage, they trained a policy with a retrieval reward and a format reward. So no answer reward like search R1. And the retrieval reward does not necessarily actually check for retrieval effectiveness. That is, it does not check how good the external evidence is or how what is the ranking of the evidence, but it just checks the number of retrieval, whether more than one retrieval call was made. So if more than one retrieval call was made, then uh, um, a reward of zero point 0.5 is assigned. So this was the first stage. So the first stage just ensured that made the model familiar to make retrieval calls. And in the second stage, they got rid of this retrieval call and they just used the answer reward and a format penalty. So the essence was like a two-stage curriculum. The first stage made the model familiar to make retrieval calls, and the second stage made the model basically try to get the answers using those retrieval calls correct. As GRPO started becoming more and more popular, many people also tried to train policies with GRPO for different standalone retrieval tasks as well. For instance, there was this paper, Rank R1, which trained a re-ranker, that is a second stage ranker, using by GRPO-based reinforcement learning. So here is what they actually did. So they started with a first stage retriever like BM25 to get the top documents, and then they constructed a set-wise ranking task, which was popular through previous approaches, where the model was shown essentially multiple documents and asked to pick the most relevant one. And so they modified the prompt to force the model to generate these reasoning tokens first and then output the final document which is the top ranked document. And the reinforcement learning reward, or the reward used for GRPO, was just the exact match with the document ID. So here you see how GRPO is used to implicitly learn better reasoning patterns or reasoning processes for ranking or re-ranking decisions. So let's try to take a look at the prompt of rank R1, how they've exactly used for re-ranking. Um, so here you can see, uh, given the user query, which of the following documents are is most relevant, and they provided the documents as a list, document 1, 2, and so on to document 20. After completing the reasoning process, please provide only the label of the most relevant document in the query enclosed in square brackets. So, for example, if the third document is the most relevant, the answer should be open think, close think, open answer, bracket 3, and close answer. So this last document ID would be used for as a verifiable reward. On the right, they've also shown a sample example of how the GRPO trained one got it right as compared to a zero-shot rank R11. So Search R1 and Research showed performance improvements on multi-hop short question answering, like Hotpot QA, 2Wiki QA, and here the final answer was like 2-3 words long. So you could still evaluate the final answer fairly directly. But then there were some other papers which extended this in various ways by defining novel reward functions and training strategies, especially for long form generation tasks where exact match would not really work. So essentially, by simply designing your reward functions, you can imagine like the number of tasks that you can extend such a framework to. So O2 Searcher, for instance, here they performed question answering for long form tasks, and hence they rewarded rollouts for format correctness, diversity, and factuality. R search was also an interesting approach. So they added an explicit evidence generation step where they not only inserted retrieve tokens but also generated summaries from those retrieve tokens. And for the answer reward, they essentially measured the quality of the evidence being retrieved. And essentially, they take the generated evidence and feed it to a different family of frozen model and have that model basically answer this question using this generated evidence and see whether that is similar to the gold answer. If that is highly similar, that means the evidence is very useful. So you can see essentially how any policies, both RAG as well as non-RAG, were rewarded by using feedback from external models or even sometimes LLMs as judges. So you could uh, basically expand the number of tasks that you could address.